Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on coordinate covalent bonds. Previously, we discussed polar and non-polar covalent bonds. We learned that polar bonds are those in which shared electrons spend more time in the vicinity of one atom than the other. Non-polar bonds are those in which the electrons are shared equally between the two atoms. We also talked about polarity, which is caused when two atoms forming a bond together have different electronegativities. We learned that atoms with higher electronegativity tend to attract more electrons than do atoms with low electronegativity. In today's lesson, we will define the term coordinate covalent bond or dative bond. We will also look at the formation of coordinate covalent bonds, as well as examples of compounds that contain them. A covalent bond is formed when one of the bonding atoms donates both electrons of the bond. This is called a coordinate covalent bond. It is also referred to as a dative bond. This equation hypothetically represents the formation of this type of bond. Once coordinate covalent bonds form, they have the same properties as any other covalent bond. The atom that provides both of the electrons for the bond is known as the donor atom. The atom that shares these electrons with the donor atom is called the acceptor atom. In order to be a donor, an atom has to contain a lone pair of electrons in its outermost shell. In order to be an acceptor, an atom needs to have at least one vacant orbital. Let us look at an example. Ammonium ion is formed when nitrogen of ammonia molecule forms a coordinate bond with hydrogen ion. There are two non-bonding electrons in the valence shell of nitrogen atom in ammonia that bond with a hydrogen ion. This is because the hydrogen ion has no electrons to contribute. As you can see in the resulting ion, the 4N to H bonds are the same. Coordinate covalent bonds can also be formed between a hydrogen ion and a molecule of water. This is because water molecules each possess 2 lone pairs of electrons. Students, please draw the Lewis structure for the coordinate covalent bond between a hydrogen ion and a molecule of water. Show what it would look like before and after the bond is formed.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure you had no trouble drawing the Lewis diagram for the coordinate covalent bond between a hydrogen ion and a molecule of water. Does your diagram look like this one? I hope so. If it does not, please make the necessary corrections. The formation of the coordinate covalent bond looks like this. Ask your teacher for help if you need to. Carbon monoxide is another example of coordinate covalent bond. Carbon and oxygen atoms form this bond in order to attain stable, noble gas electron arrangements. In this case, oxygen is the donor atom and carbon is the acceptor atom. Students, please work with a partner to answer the following questions. How are coordinate covalent bonds different from covalent bonds? What is a donor atom and what does it require? What is an acceptor atom and what does it require? Please write your answers onto a piece of paper and we will discuss them in a few minutes.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Were you and your partner able to answer all of the questions correctly? Let us go through each one together so you can check. Coordinate covalent bonds are different from covalent bonds in that just one atom donates both of the valence electrons for the bond, rather than each atom donating one. Once the bond has been formed, there is no other difference. A donor atom is the atom that provides both of the valence electrons for the bond. Thus, this atom must have a lone pair of valence electrons. An acceptor atom is one that shares valence electrons with the donor atom. Acceptor atoms must have at least one vacant orbital. I am sure that you had no problem answering those. Well done, students! In today's lesson, we discussed coordinate covalent bonds, which are also referred to as dative bonds. We learned that these bonds are covalent bonds in which one atom donates both electrons of the bond. Once coordinate covalent bonds are formed, though, they are just like any other covalent bond. We learned that the atom that contributes the valence electron pair to the bond is known as the donor. We also learned that the atom that shares the valence electrons is known as the acceptor. We learned that coordinate covalent bonds occur when there is an atom with a vacant orbital that requires an electron pair, and there is another atom that has a lone pair of valence electrons. In our next lesson, we will learn about the general properties of covalent compounds. We will discuss an experiment in order to investigate the effect that heat has on covalent compounds. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.